So Google recently published this A2A protocol, and on their official documentation, which I'm referring, they say it's a protocol that unlock collaborative agent-to-agent, very important, agent-to-agent scenarios with a new open source protocol. So basically they are trying to say that this new protocol that has come, and if you know, Anthropic recently launched MCP, Model Context Protocol. So how is MCP different than this A2A, agent-to-agent protocol? So yes, we are going to dive deeper into the differences of both and what exactly is there in this A2A. So we will come to that. Plus, we are also going to go through all of this documentation pages and the agents that they have shown as examples with Creo AI, LangGraph, Agent SDK by Google itself, like how exactly A2A can be a part of that agentic system. So hi, my name is Akshit and I work as a developer relations engineer at Maxim AI. In this video, we'll be diving deeper into A2A protocol. So before we go and jump into the technical jargons, let's first of all see some real life example. So over here, let's assume you are a user, or let's say you are a customer and you're very hungry. So for that, you go to a restaurant and over there you are going to see a waiter and you are going to give the waiter your order, whatever you wish to eat, right? So we can say that this waiter has certain task. Let's say the task of this waiter is to take the orders, like when the food is ready, he or she has to present the food, so presentation is there. And let's say he or she also is responsible for garnishing the final food product, right? So we can say that this complete thing is an agent itself, is a complete agentic system itself, because it has an entity which is a doer, like who does something, so waiter. And then we have certain tasks or tools, we can say, which this agent has access to. So I can say that these are nothing but my tools or the task which are associated or assigned to this waiter. But in order to fulfill the request of the user and the customer, the waiter agent is not enough. At the end, this waiter agent has to communicate with another agent who will be the chef agent. So we can say that this is another individual agent, and this agent also has certain tools and tasks associated to it. This chef has access to the gas stove, that means he can cook. He has access to the air fryer so that he can fry something, and he also has access to the microwave so that he can bake a cake or cookies or anything. So both of the agents are there in our environment and they have certain tools and tasks associated to them. And we know that they both need to talk to each other, they both need to communicate with each other to fulfill the final request of our customer. And if you have watched our MCP video, you will realize over here in our individual agentic system, when the chef agent has to get access to certain tools, right? Let's say the gas stove, air fryer, or microwave. This is a real life example, but in actual case, let's say you are building an agent that has access to your file system, your databases, or your local computer system. There we use MCP so that the LLM can be provided with the best context out of these resources. So we can say that whenever the agent needs to get access to certain tools or use those tools, there we use MCP. So we can say that MCP will be significant at this step. Each of these resources will have their own MCP servers, and our MCP client will be talking to these MCP servers to get their task done. And using this chef agentic system, I'm just trying to give you a real life example. Similarly, over here also, MCP will be useful when the waiter agent or the MCP client has to do these tasks or need access to these resources or the tools, we can say. Now let's zoom out a bit and see what needs to be done. Our waiter agent has to talk to this chef agent, and first of all, this waiter agent has to detect or figure out which chef agent is free and can take an order. So this agent has to find out in the kitchen who is the chef, and based on the order that we have got from the user, whether that chef has that capability or not. Let's say this chef can only prepare seafood, and let's say the order is Indian cuisine, then it doesn't make sense to give that order to this chef. So we can say that in an agentic system where there can be multiple agents, one agent who has got the task has to find out another agent who can do a part of the task in the best possible way with the correct required capabilities. And one more thing that we're forgetting, that this chef will not take an order just from a random person. Let's say directly this user asks the chef to prepare the food. The chef will not accept it. The chef will only accept the order from this waiter. That means there is some kind of authentication authorization thing going on between the agents, that one agent will accept the task or give the response to another agent if the first agent has proven itself as an authenticated agent or an authorized agent. And in the last 1 minute, whatever I said is possible in the real agentic systems using A2A protocol released by Google, which is agent to agent protocol. So we can say that whenever an agent or the MCP client has to talk to the MCP servers, there we use MCP protocol, and Anthropic has solved it very well. But whenever an agent has to talk to another agent, that time we have to use A2A protocol. So this communication will be happening via the A2A protocol. So A2A will exist at this level. I hope this makes sense. Now, because you have understood the basics, let's jump on to the official documentation by Google. As you can see on my screen, there is one agent who has sub-agents, the local agents, and you will be having an LLM that can be Gemini, OpenAI, or Claude. Any model can be there. And then you will need a agentic framework that can be ADK, which is recently launched by Google, or it can be Crew AI, LangGraph, OpenAI's Agent SDK. It can be anything. And then the complete agent will be talking to the APIs or applications or tools via the MCP. But if this agent has to talk to another agent, which is kind of a black box for this agent, and this agent needs to know its capabilities, then we need A2A protocol, which is nothing but agent to agent protocol. And you need to understand that this agent will not know how this agent capabilities are implemented. This agent will only get the capabilities JSON or a very high level information about the capabilities of another agent. For the first agent, the second one is just like a black box, but with a manual of how to use or communicate with another agent. And if you go to the technical documentation, you will actually find a very detailed explanation of this complete protocol with every component explained. As you can see, just summarizing whatever we learned from the chef example, there is an end user, then we have a client. The client will communicate with the remote agent, and wherever you are seeing the green checkboxes, there the A2A protocol is coming into picture. That's how these 4-5 agents are communicating with each other. If you go to the key principles, first of all, A2A and MCP, like what exactly is the difference? And that I've already explained, like where which part is taken care by MCP and which part is taken care by the A2A. Next thing is the agent card. So over here, every agent, A2A protocol says that every agent should have one agent card. Let's say this chef will have an agent card over here, which will show that what are the capabilities of this agent, what is the name of this agent, some description of this agent, so that it becomes easier for another agent to find out whether this agent can do a task or not. So that information is present in the agent card. So over here, as it says, remote agents that support A2A are required to publish an agent card, and that is compulsory, in JSON format describing the agent's capabilities and skills. And authentication mechanism. Clients use the agent card information to identify the best agent that can perform a task and leverage A2A to communicate with that remote agent. This agent card will be helpful in the discovery of an agent, and as it says that the agent card needs to be hosted on well-known /agent.json, which is explained over here, that if you want to let your agent get discovered, then they recommend, the A2A protocol, Google recommends that you host your agent, let's say at a base URL, and after that you have another file, .wellknown /agent.json, that will hold all the information in the JSON format about this agent, as we call it as an agent card. This is compatible with the DNS approach, where the client finds the server IP via DNS and sends an HTTP GET to retrieve the agent card, which is present at this location. We also anticipate that systems will maintain private registries, agent catalog, or private marketplace, which are yet to come. So Google also said that they are also working on some agentic catalog or a marketplace of the agents, where all these agents can communicate with each other via A2A, but Google is still working on that. And below you can see the actual implementation of an agent card. So if you have built an agent, let's say using Crew AI or LangGraph, then in that agent you need to define your agent card just like they have done over here. So this is TypeScript code where they have created an interface called agent card. The agent will have its name, description, the URL where it is deployed or hosted, then the provider, the version, and you can see the capabilities are there, how the agent is going to get authenticated, that all information is there, plus the skills are over here. So this is important, and this is called the agent card. Then below comes some more objects which A2A protocol holds in itself. One is the task, like what exactly the task is that an agent can perform. So over here you can see the interface for that. The task is there, ID, session ID, status, history, artifacts. Artifact means the thing or the resource that is generated by the agent. It can be text, file, image, anything. Then we have an interface for task status update event, like some events are going to be there which will update the task status. So that all you can understand by reading through this documentation, and I think that this documentation released by Google is more than enough for you to understand A2A at this point of time. Then you can see the artifact object. Artifact, as I said, it is nothing but a thing or an entity that is generated by the agent. Then comes the message. Message will contain how the agents can communicate with each other. It can be the final response or the request data. So as you already know that whenever we need to communicate to an LLM, we need to define a role, whether it's an user or an agent. Then every message will have certain parts, because you already know that LLM does not generate the complete response all at once. It generates in parts, and this part represents one single unit part of the complete response. And then you can also have some metadata, and there below you can find the interface for one part. It can be a text part, file part, data part. Then comes the push notifications. This interface defines the schema for a push notifications, which are helpful when an agent has to notify about something to the end client. And that's it. Then you can read some more examples of how to send a task, how to get a task, cancel a task, send some notifications. All of that is available over here. If you check out the agent discovery, as I told, currently we have the support for open discovery, where Google recommends enterprises host their agent cards at a well-known path, which is we have already seen that you define the domain, and at that domain you have well-known/agent.json, which will contain the JSON schema for the complete information about the agent, and just using a get call, this information can be retrieved by another agent or even the web crawlers to figure out whether this agent is helpful or not. Then we have registry based. As I told, Google is considering adding registry support to the protocol, which is still in progress, so no comments on that for now. Now let's go through an agent built using Creo AI. Over here, as you can see, this is a Creo AI agent which is helpful in generating images. So as you can see, we have a Creo AI agent. It talks to the Gemini API for generating an image and then getting the image back from Gemini. And we have an A2A client and A2A server which can easily communicate via A2A with this Creo AI agent and get the task done. So let's go through its code and see where exactly is the agent card is present, how exactly it is giving a task, getting a task. So let's see. So if I go to the Creo AI folder, over here in the agent.py, you have two main files over here. One is agent.py, another is taskmanager.py. So first of all, let's go through the agent.py. Over here, as you can see, we are first of all defining the tools that will be useful in performing a task. That can be for generating a file. As you can see, this tool generates an image or modifies a given image based on a prompt. And then we have an image generation agent which will have access to this tool. We are just defining the task for it, and it has the tool access. And then finally we have the Creo, which will have all the agents defined, the tasks defined. For now in this agent we only have one agent and one task, but there can be multiple. It has to execute the process in the sequential mode, and then you get the file back. So this is the agent implementation. But if you will see taskmanager.py, so in this file, we have an agent task manager that manages all the tasks for an agent. Let's say when like on send task function is there, on send task subscribe function is there, get user query function is there, which receives a user query, and based on the query, it figures out what needs to be done, whether to generate an image or generate text. And finally, we get the artifacts which are bundled and then sent back to the client. In the main.py file, you will actually find the agent card. So over here, as you can see, the complete agent is now ready. The Creo agent is ready. In the main function, you are going to see the capabilities of that agent, then the skills of that agent, the agent card, which has the name, description, URL, version, capabilities, and skills, as we saw in the documentation. And then we have A2A server, which will have this agent card, the task manager so that the task can be performed by the agent, and the host on which this agent is deployed. We are not doing a lot of extra things that we used to do before A2A. We are doing the same things. We just have some more couple of functions and tasks that needs to be done, and it will make our life easier when we need our agent to communicate with other agents. So I hope you like this video. In this video, we'll just try to give an introduction to A2A. In the future videos, we will be diving deeper into A2A and maybe building some coding projects. So till the next video, best of luck for your AI journey.